So it's the next day, and as you can see, we've gone backwards. So I went to reassemble this and test out functionality after recapping this amp board, and had all sorts of things went awry. Had all sorts of oscillations, excess current draw, etc. Basically, bottom line is we have one shorted output capacitor. Transistor, output transistor. So we're going to replace all four of them. The culprit, as best I can see, after inspecting all my work, not finding any solder bridges or anything there, the only thing I can think of that it would be least likely a defective capacitor. Although that's not beyond possibility, I can't say I've ever experienced that. I did a quick check on them and don't see anything bad. But what I did find is this STV3 bias diode, or it's actually more of a thermistor type situation, but it looks like a double diode on the schematic. The lead had become broken and unattached from this pin right here, and I did not notice it until I pulled the heatsink and the board, separated the two. So what I'm thinking is that being out of circuit caused thermal runaway, excess current draw, and ultimately killed that output transistor. So this just furthers what I was saying about testing after you do each section, because obviously had this happened and I had done the whole amplifier, power supply, preamp, phono amp, it would have been probably a little more difficult to track down where the source of the problem was. So I'm going to reinstall these, or install these new output transistors. By the way, the originals are 2SC 1030s. The ones I have selected are from onsemi. They're MJ2 1194Gs. These are much beefier than the originals. 250 watt capacity. Over spec'd for this job, but should do well. So hopefully reattaching that lead is going to solve the problem. I'll stress another point, and this is my own fault. Should have used a dim bulb tester to bring it up, even though everything worked fine with this receiver before starting this. As you can see, things can go awry, and that might have saved that output, maybe not. But as you can see, I do have one, and I also own a Variac and used neither, so my bad on that. And I guess I should not get overconfident sometimes that everything's going to work out fine, even though 99% of the time it does. Here's a great example of what happens when it doesn't, and what kind of setbacks we have and extra expense we've incurred on this project. So enough of my preaching. We're going to go ahead and get this together and see if that fixed the problem. So this many parts later is what it took to get the amplifier back online. I installed the new outputs, still had some instability, and kind of knew going into it that there was a good chance that the drivers were compromised when that output shorted. So we replaced everything, pre-drivers and drivers, with suitable replacements, which are better quality than what they had back in '72 when this was built. Much lower noise, a little better gain specs, and just getting ready to adjust the bias. We did bring it up on the dim bulb, and everything is good. So I went ahead and did the output capacitors and the large filter as well. So I'm going to go ahead and set the bias on this, and we will continue on with the power supply and preamp and phono amp. Amp's been on for about 10 minutes now. You can see we have very stable bias, 7.5 millivolts. Everything's looking really good. Also popped the LEDs in there too. That look really nice, but I'll get a better shot of that once we get finished up with the rest of this. There are the new filter and output capacitors. I will kind of detail a little more later on how I did that one, because it didn't quite fit perfectly in the holder ring. More to come in a little bit. Okay, we have our preamp board done, all recapped. Didn't have to address any of the transistors in this one. It looks like somebody had already addressed that in a previous repair. These all have been replaced with the 2SC 2240s, which are don't believe they're made anymore, but they believe they were as of maybe 3 years ago, and were the preferred low noise replacement for these preamp boards. So got lucky there, didn't have to deal with those. There's 6 of them on the board. But as you can see, this is going to be your easiest way to work on it. Just take the 4 screws loose, undo any wires to give you the slack you need, and some helping hands like this really makes it a lot easier to deal with. But there we go, got all our flux cleaned off the back of the board. It's looking nice. We're going to go ahead and reinstall this. Move on to the phono section, and then do a final test, and that'll complete this restoration. Alright, so here we are with the final stages of this Marantz 2220. As you can see, we have completed the phono section. One thing we did have to do other than the capacitors is we had to replace a couple of small signal transistors. And they're these guys right here. See if it'll focus on them. Come on. These 2SC458s. Now you can kind of make you can spot these pretty easy. Not saying that every transistor this shape is one of these, but you can definitely spot these pretty easy by their shape. These are what would have been in the preamp section as well, had somebody not done some previous service work before. We have the faceplate back on. See if I can get you a better shot of that. It looks pretty nice with all the LEDs. And what we're doing right now is just double checking the bias. Just because I did do 2 more stages of the receiver itself. Sometimes old capacitors, leaky transistors can drag down the power supply a little bit. So when those are all refreshed with new, they can affect the bias. So I had the bias roughed in already before starting the last 2 sections, but I'm going in and doing the final adjustment right now. And I like to let it sit here. I have 2 meters, 1 for each channel. You can see. That makes life a lot easier. And I like to let it sit here for about 30 minutes, get the amp good and warm, up to full operating temperature. And I just kind of, periodically glance at the meters and see that the 2 channels are tracking evenly, which they're tracking very evenly. In fact, usually it doesn't get quite that good. Usually they're a couple of millivolts off from each other, but these are tracking very nicely together. And recommended idle current or bias for this machine is 7.5 millivolts. You can see we're already over by a millivolt at 8.4, but that's okay. We're going to let it sit as it is for about 30 minutes, and then I will back it down to where it needs to be, and that will be its final adjustment. What else? That's pretty much it, other than the real test, which is going to be the listening test, but everything seems to be very stable and everything's looking good. So I hope you found this this video helpful if you're planning on doing a recap and restore on a vintage receiver of any brand, Pioneer, Kenwood, Marantz, Sansui. Hopefully some of these tips and whatnot might be of use to somebody. And if you are doing a Marantz 2220, well, now you know exactly what you're in for, and this will pretty much apply to 2220, 2230, very similar. 2245 is going to be similar, with the exception that it is a direct to DC coupled amplifier. It's not a capacitor coupled, so you'll have one less large can cap, and you'll also have a protection circuit to deal with, which is part of the power supply. But a lot of these in the 22XX series are going to be pretty much the same. So again, thanks for watching, and hope you guys found this useful. I forgot one last thing. I had told you guys that I would show you what I did here for these large can capacitors. So you can see that the newer ones are shorter than the originals. Here's the originals over here. The two coupling caps are the short ones, and the big one, the tall one, is the filter capacitor. But the new ones, you can find them that are pretty much the same size, but you're going to pay a lot of money for them, and it's really not necessary to do that. These are good audio grade Nishikans. And what I try to do is I don't really give a lot of concern to how tall they are, but I try to get the same diameter, for the obvious reason that you want to be able to use that clamp system over again to mount them. So you can see the two coupling caps are the same diameter, and they are just shorter, and they mounted in there really nice. The large filter capacitor, however, I could not find one that was 40 millimeters that was reasonably priced. I could find one, but I wanted to keep them all the same series of capacitor, and I didn't want to pay an arm and a leg for it. So that's a 35 35 millimeter in diameter capacitor, and all I did very simply is I wrapped one wrap of foam weather strip tape around it to kind of build out the diameter a bit, clamped it down, and then just to make doubly sure that it was secure and would never fall down, because if that happened it would short against a metal bottom, because I ran a bead of hot melt glue around it. It can easily be removed. Hot melt glue peels off real easily. If for some reason it ever needed to be removed, but it's not gonna, there's no risk of it falling down in there. So that's just how I do it. I'm sure there's plenty of other methods out there, but that's how you can deal with that. If you want to try to keep costs reasonable and get decent quality capacitors, but maybe want a little bit of flexibility with the sizing of them. So there you go. Just wanted to add that in. Forgot about that. And again, hope you guys enjoyed. Thanks.